Hi viewers, in this video let me see about common emitter amplifier, common emitter configuration. In my last video, the video title is concept of amplifier. We see that amplifier is the two-part network. It has 4 terminals. Input port and output port. 2 port, input port and output port. So amplifier is the 2-part network or 4 terminal network. Input port, output port. So the basic electronics component which will act as the amplifier is nothing but BJT, that is bipolar junction transistor. So the bipolar junction transistor is the basic electronics device which is used as the amplifier. Say the transistor BJT has 2 types of transistor. One is NPN transistor, another one is PNP transistor. So this is NPN transistor, this is PNP transistor. 2 types of transistor available, NPN and PNP transistor. So in the last video itself I explained that transistor having only 3 terminals but amplifier having the 4 terminals. In order to make this 3 terminal into the 4 terminal network, we should keep one of the terminal as common for input and output. Now we are seeing about common emitter amplifier. The letter common means the emitter terminal. Common emitter means the emitter terminal is common for both input and output. In this video we discuss about NPN transistor. The next video we can discuss about PNP transistor. In the NPN transistor we keep emitter as the common terminal for input and output. So while we are keeping emitter as common terminal, we should know which 2 terminals are input and which 2 terminals are output. So the emitter is common. If this arrangement is called it as common emitter configuration, common emitter configuration amplifier. So when we are keeping emitter as common, we should know which terminal is input, which terminal is output. First we should know about this. So in common emitter amplifier, base terminal is input, collector terminal is output. So that base to emitter is the input port, collector to emitter is the output port. Base to emitter is the input port, collector to emitter is the output port. The second letter indicates the common terminal. Okay, base is input, collector is output. Now we see about the configuration. Actually this also the configuration. That means if you are keeping emitter is common, base is input, collector is output. So this arrangement is a configuration. This is not only a configuration. Let me see about the biasing also the configuration. So in this video the biasing is the new word. So far we are not discussed about biasing. In my last video I explained about the faithful amplification. So in order to achieve the faithful amplification, we should properly bias the BJT. Later we will define what is meant by biasing. Just we have to remember what is faithful amplification. So in the last video I explained that the shape of the signal should not be altered while amplifying the signal. Okay, so this is input signal which is weak signal. This is output signal which is amplified signal. That means strengthen the weak signal. Okay, strengthen the input signal. Then now the signal is very strong, but the shape of the signal should not be altered. Okay, the signal shape of the, for example, suppose the input signal is like this. If the output signal is like this, then the amplification is not good. It is not a faithful amplification. Suppose the input amplifier is look like this. The amplified output signal is like this, means it is distorted. This is also not a faithful amplification. This is distorted signal. Okay, this is only the faithful amplification. In the faithful amplification only the message amplified in the correct manner. If it is the message is distorted, lot of error will occur. So the wrong information present in the output signal, that is the meaning. So in order to achieve faithful amplification, we should properly biasing the BJT. We should properly biasing the transistor. So what is mean by biasing? Why we have to bias the signal? So the second question, why we have to bias the signal, is nothing but we should achieve the faithful amplification. In this case, later we will detailedly analyze about some other reason also there why we have to properly bias the BJT. So right now just we know about, in order to achieve the faithful amplification, we should properly bias the BJT signal. That is the reason why we have to bias the amplifier or BJT. The first question, what is mean by biasing? Biasing is nothing but adding extra DC signal, adding extra DC voltage to the BJT. Adding extra DC voltage to the BJT. I am using the word adding. What is the meaning of adding? Why we have to use this? See, the amplifier input is the weak signal. Amplifier output is the strong signal. So this is input signal, this is output signal. Apart from the input signal, we have to give the one more input signal, that is a DC signal. This signal may be AC or DC. This signal almost AC. Okay, the input signal almost AC. AC signal only we have to amplify. Otherwise, this signal is a continuous signal. Okay, so this is only the input signal. So apart from the input signal, we have to add one more input as a DC signal. The extra DC signal we added to the amplifier is a biasing voltage or biasing signal. So why we have to do this one means, like we say, this one is a common emitter amplifier. In the common emitter amplifier, if I am giving the input AC signal, it will be amplified like this. Usually it should happen in such a manner, then only we can achieve the faithful amplification. But this one we cannot achieve without DC biasing signal. Let me see what is the reason. See, we go to the layer of the BJT amplifier. In the layer of the BJT amplifier, there will be the 3 layers. One is emitter, base, collector. There is the 3 layers. This one is a NPN transistor. So emitter is a N layer, base is the P layer, collector is the N layer. N and P are the semiconductor layers. So if N and P is joined together, there will be formed the junction, PN junction, J1 junction. Similarly, here base to collector, another one junction, J2 junction is there. This one is a PN junction. So in the PN junction, there is the barrier in the junction. Okay, if you are giving the input signal in the emitter, initially it does not cross across the junction J1 and J2 and it reaches the collector. Initially it does not happen. What is the reason? J1, J2 are the barrier. So some barrier potential in the J1 junction and J2 junction. For example, if it is maybe the silicon type material, 0.7 will be the cut-in voltage. Otherwise it is germanium, 0.3 is the cut-in voltage. So, to overcome the biasing potential, we need a 0.7 voltage for silicon, 0.3 voltage for germanium to cross this junction. So this voltage is called it as a cut-in voltage of the PN junction, 0.7 for silicon, 0.3 for germanium. So only after reaching this 0.7 or 0.3 voltage, the junction will be broken and this input current freely passing through the layers and reach the output collector terminal. Suppose if I am giving the input signal, for example 0 to 1 volt, let us consider 0 to 1 volt. So if I am not giving additional DC voltage, what will happen in the transistor? In the output side, the amplified signal may be 10 volt. Let us consider 10 volt. The 0 to 0.7 voltage in case of silicon. This 0 to 0.7 voltage will not appear in the output side. The reason is the 0 to 0.7 voltage will lose to overcome this barrier potential. So after 0.7 voltage only, the output signal amplified and we can get the output signal. Okay, so if the input signal is like this, if you are not properly giving the biasing additional DC voltage to the BJT, what will happen? 0 to 0.7 voltage will be disappear in the output and the output signal look like this. Now this is not a faithful amplification. This is not a faithful amplification. This is some distorted. In order to overcome this, we need a additional voltage as the biasing voltage. Okay. See, in this video, I explained what is biasing potential, why we have to use the biasing potential. So we have to properly bias the BJT amplifier. Okay. So now we are consider the NPN transistor. So the biasing arrangement is nothing but we have to add the DC signal to the amplifier. Initially we have to add a separate DC signal for the input and the output. That is called it as a configuration. The arrangement of input DC signal and output DC signal to the BJT is called it as configuration. Okay, so common emitter configuration. Already we see that the common emitter means emitter terminal is common, base terminal is input, collector terminal is output. After that we have to provide input DC voltage and output DC voltage to bias the common emitter amplifier configuration. So this DC input voltage is not actual input. The actual input is the input weak continuous signal. Okay. In order to avoid the distortion and to achieve the faithful amplification, we have to properly giving additional DC voltage. That arrangement is called it as biasing. So configure the common emitter. We should know about the symbol as well as layer diagram. Okay, so this is a NPN transistor symbol. The layer diagram, first one is emitter, then base, then collector. This is emitter, base, collector. This is emitter terminal, this is base terminal, this is collector terminal. Emitter, base, collector. This one is NPN. So NPN. The emitter layer is N, base layer is B, collector layer is N. Okay, this is base, this is emitter, this is collector. Okay. So in the common emitter circuit we use the symbol and we can draw the circuit. So base is the input port, collector is the output port, emitter terminal is common for input and output. See, already we said that this BJT arrangement will act as the amplifier. The input port should be forward bias. The output port should be reverse bias. So there is the two junction, J1 junction, J2 junction in the transistor layer diagram. In this arrangement, that is common emitter configuration, J1 junction is the input junction, J2 junction is the output junction. Okay, so we should make input junction J1 is forward bias, output junction J2 is reverse bias. Okay, the reason to make the amplifier, the concept of amplifier, input should be forward bias, output should be reverse bias. Okay, so in the PN junction, so PN, let us consider this may be the PN junction. If P material gets the positive voltage with respect to N material, if P is positive, N is negative, then it is called it as forward bias. In the PN junction, P gets the negative voltage, N gets the positive voltage, then it will be the reverse bias. Okay, so now we have to make input is forward bias. Input B terminal is a B layer. This is the B terminal. B terminal in the NPN transistor is the P layer. So this is a P material. Okay. So collector is a N material. So the input should be forward bias. Input should be forward bias means P layer should get the positive voltage. So the P layer gets the positive voltage. N layer gets the negative voltage. So N layer gets the negative voltage. So we should arrange the DC voltage in such a way. B gets positive, emitter gets negative. Base get positive, emitter gets negative. Now the input J1 junction or input port is in the forward bias. Similarly, the collector is the N layer. So output should be reverse bias. Output should be reverse bias. So N gets positive means it is a reverse bias. Here the collector is the N material. So we have to provide the positive to the N. Then the J2 junction will be the reverse bias. Otherwise the output port will be the reverse bias. So positive, negative, negative to the emitter terminal. This is a common emitter configuration. In the common emitter configuration means the emitter terminal is common, base terminal is input, collector terminal is output. Input should be forward bias. We make the additional DC voltage like this. Output is the reverse bias. We should make the output DC voltage connection like this. This arrangement, this is the biasing arrangement of the common emitter amplifier. Here we are using the two separate DC source, one for input, one for output. This arrangement is called it as a common emitter amplifier configuration. We have to bias in such a way. I hope that this video may be helpful for you. Kindly subscribe this channel and share this video to your friends. Like the channel also. Thanks for watching.